everyone, in today's video I will be delving into the tuning potential of the 4AG engine in naturally aspirated form. Firstly, I would just like to expound that there are two ways to increase the power and torque with the 4AG in naturally aspirated form, and that is either revving the engine high or increasing the displacement. The former is very true at the time of the original Group A and N2 series, as the stroke of the crankshaft cannot be tampered with, and the engine was also homologated to run in 1.6-liter form. Now moving on, let's start by how can you go about increasing performance whilst not altering the displacement and still remaining naturally aspirated. The first step here is to increase your compression ratio. Please do bear in mind though that the fuel you use will limit how high you can go whilst abstaining from the knock limit of your engine and fuel of choice. The second step would be to port and polish the cylinder head, and also to install bigger valves to ensure that you would have the needed airflow in order to make power at high RPM. Let's say from 8,000 RPM onwards, similar to the old Formula Atlantic 4AGEs. And it's also important to note that you would also have to install high lift and duration camshafts in order to make the power at higher RPMs, because all of that port work and bigger valves won't be utilized to the fullest if you were to use a mild cam that doesn't open the valves big enough and long enough. Of course, as the RPMs increase, the loads on the engine components gets multiplied exponentially. That is why it's important that the pistons, connecting rods, crankshaft, and valve train components such as valves and valve springs need to be of a higher quality and strength in order to have a reliable high horsepower, high RPM engine. That's all well and good, but the downside is that as we are talking about the 4AGE here, and once you push the maximum RPM that you are operating at past 9,000 RPM, the engine's life expectancy gets reduced due to the increased load and stress high RPM operation does to the engine, and even though high quality parts are used, the wear and tear would be far greater than if it's operated at, let's say, 9,000 and below. This isn't a problem for a race engine, as this type of tuning was intended for back in the day, and the engines get rebuilt every race meeting. But for something that is to be used on the street and is your daily commute, high RPM is not the answer, because you won't have any power and torque down low, and all of the performance is realized at only the higher RPM ranges, let's say 5,000 RPM onwards, and what you need on the road is the low to mid RPM power and torque to give you pleasant drivability for climbing hills and overtaking as an example. That is where the second school of thought of tuning comes in, wherein altering the bore diameter and stroke length increases the overall displacement of the engine. And this improves both power and torque throughout the rev range without sacrificing low-end power and torque. This also means that you can use a milder cam to achieve your power and torque goals, as there is more displacement, and that displacement increase helps you aim for more power and torque at a lower RPM than if you went with the high RPM route and sacrificed the engine's durability and longevity. It's also important to note that this also affects the rod-to-stroke ratio of the engine. If you would like to learn more about rod-stroke ratios, I'll leave a link down in the descriptions below. Now, increasing the stroke also calls for altering the length of the connecting rod as well as the compression height of the piston to ensure that there won't be any piston-to-valve contact. But the current crop of stroker kits from the likes of BC and MRP already has had this aspect considered, so you won't have to. I'm in no way, shape or form am I being sponsored by these companies. I'm just sharing what I've worked for myself, and hopefully that would also help you out in planning your new engine building project. Personally, I tend to go with MRP since the parts are so well engineered. Now we have a lot of kits to choose from nowadays, but back during the late 80s, HKS had developed a stroker kit that had an 83mm stroke crankshaft that would turn your 4AGE into a 5AGE, as they called it back in the day, which would increase the displacement from the original 1587cc to 1731cc, which is an increase of 144 cc's, which is really big considering that it's almost a 200cc increase in displacement. This is why, sorry about that, tuners back in the day called it a 1.8-liter kit, in which it is 69cc shy of being a complete 1800 cc's of displacement. The HKS kit also comes in different coded compression ratios, so that you can choose which kit suits your requirements. Regarding compression ratios, they range from 8 to 1 all the way to 11.3 to 1 compression ratio. Furthermore, this kit requires clearancing the block so that the crank and rods won't hit and have interference issues with the block and cylinder head. I would also like to note that using the late model block from the AE92 is highly recommended, since this block is similar to the block in the 4AGZE equipped MR2, which is much stronger than the earlier 3-rib blocks found in the AE86 and AE82. Using the 20-valve block is also a viable option, as it is similar to the AE92 7-rib block with some minor differences due to the 20-valve application. Moving on, there is also a couple more variations on how much displacement increase you would want from your 4AGE. There's the 4.5 AG, 5.5 AG, 7 AG, and 9 AG, to name a few. Let's first begin with the 4.5 AG. I do highly suggest going this route if you're low on budget and can't afford a stroker kit, or you already have a 3-rib block that you want to use rather than buying a 7-rib block. Basically, this specification is just a bore-up specification wherein you would get your machinist to bore out the block to 83mm. Bear in mind, please do let the machinist check out your block if it can handle an 83mm bore, since not all blocks are equal and some do have some core shift that would limit you not going with this route. In the case that you're not able to get the block bored out to 83mm, then I would suggest getting it bored out to 82mm, which is a happy medium if indeed you have some core shift, and you would still merit from the extra displacement increase. The displacement increase from the bore up would be 39 cc's for the 82mm bore up and 79 cc for the 83mm bore up. Now, the 5.5 AG specification is just a combination of the 5AGE stroker kit with an 83mm bore similar to the 4.5 AG, and that would get you to 1796 cc's from the original 1587, and that is an increase of 209 cc's. For the 7AG, however, is a bit more complex, since you would need to use a 7A FE block and made it to a 4AGE cylinder head. Now you can do what the old tuners did back in the day in Japan and just make the thing work using factory 7A FE parts, with the exception of the pistons to suit the 4AGE cylinder head, and machine the crank sprocket so that the timing of the crank to the cams won't be off by 10 degrees, as well as use a 4AGE oil pump, as the factory 7A just doesn't produce enough pressure as well as flow enough. I would also like to mention that you would also be needing to use the crank sprocket from the 4AGE. That is why it's more cost effective to buy a stroker kit along with the necessary components needed to do the complete 7AG conversion from the likes of MRP or tecart, but personally I would go with MRP, since they sell a complete kit and will also offer you advice on your particular build. I am in no way, shape, or form saying that tecart is no good, but I'm just suggesting going with MRP since their products are well engineered and would be easier to communicate with for English speakers. But if you live in Japan, I suggest going with tecart or Koizumi Shokai, as they provide the customers with great service and their parts are also well engineered. And in my experience, they're the best place to go if you would like your 4AG powered vehicle to be maintained if you don't do your own maintenance, and for modifications as they have a wealth of knowledge regarding the 4AGE and will offer you services tailored to your needs. Now for the important matter, which is the displacement of the 7AG conversion. That would be 1806 cc's from the combination of an 82mm bore and 85.5mm stroke. Lastly, the 9AG is just a 7AG but with a 90mm crankshaft to achieve 1.9 liters of displacement. In the past, RS Yasu, a well-known body shop and tuner in Japan, bored out the 7A block to 85mm and used custom CA18 pistons as well as an offset grinded stock 7A crank to achieve 90.5mm of stroke and 2 liters of displacement, similar to the old 2TG Kai back in the day. Again, please do check out MRP as they have a 9AG stroker kit available and is by far the best out there currently. As you guys would have mentioned, I did not elaborate upon camshafts for the combinations, as the camshaft you choose to run should be catered on how you would be using your engine. I suggest going mild if it's for a street car and aggressive, high duration and high lift for a race car as a rule of thumb, but also do inquire with the specific cam manufacturer where you are intending on buying cams from on what they suggest running for your intended application. Personally, I just run the Kelford Rally cams as they're good for daily use and that occasional spirited driving. And that concludes today's video. And if you liked the video, do like, comment, and subscribe for more. And do follow me on Instagram as well. The link would be down in the descriptions below. Until next time, have a good one.